Okay, so now we are going to start chapter 7, and the rest of the trimester is basically about making predictions. So if you remember clear back to chapter 1, it says that statistics is the science of collecting, organizing, analyzing data, and then making predictions about it. So that's what we're going to do basically with the rest of the trimester, is different ways to make predictions. So this first one is we're going to talk about predicting the population mean. So what we do is we have to collect a sample, and then we use that sample data in order to make a prediction about the population. We can do this for all sorts of things, but we will only do the mean. You can do the variance, the standard deviation, other things, but in this class we only do the mean. So some of you have heard this little activity, I guess you could call it, that I do, where usually I show you a picture of myself and ask you to write down what age you think I am in the picture. Unfortunately, I don't have that with me, so I can't do it. But what you're doing when I do that is you're coming up with a point estimate. So a point estimate is a single value that represents a parameter. And the parameter we're going to use is mu, the population mean. So usually we have no idea what the population mean is. So the best point estimate we can ever give for the population mean is the sample mean that we have. So the best point estimate of mu is x bar, the sample mean. Okay, so then what I do, once you guys write down your number that you think I am in that age, I ask what the numbers are, and usually they range from somewhere from 14 to 18. So what you've just done is then, instead of having one value that each of you did, we put them together and we make an interval. So the reason we want to do an interval is because that gives us a better chance of getting mu right. Okay, so what this is just a range of values that mu could fall in. Now you're going to notice, if you look at my other notes, this is a lot less written than the other notes are, and that's fine. So if you can just figure it out from this, that's fine. Otherwise, if you want to look at the other written down notes, that's fine also, whatever is best for you. Okay, so again, each person would write down a single number, and then we look at and find the interval or the range of values that you think it could be. Usually it's from 14 to 18. So then I ask, how confident are you that my actual age in that picture falls within the 14 to 18 that most people come up with? And most people say like 80%, they're 80% confident. So then my question is this: what if I wanted you to be 90% confident? Then they say, well, then I probably would go from 12 to 20. So if you notice, if you want to be more confident, you need to increase your interval, because then you have a better chance of it going in there. The truth is, I'm actually 24 in the picture, so most people never get that right. So then I always say, if you want to be 100% confident, then everybody thinks it's funny to say, well, then I'd have to say you're 0 to 90 or whatever. So again, just that idea of, if you want to be more confident, you actually have to widen your range of values. Okay, if you don't care about being super confident, then you can make your interval smaller. So you might have a better estimate of your mean, but it's more likely that it's not going to actually fall within there. Okay, so again, confidence level, this is going to be picked ahead of time for you. Okay, so then what we're going to do is we're going to make a confidence interval. All right, so it's going to, and we're going to do an example while I'm writing some other notes. So we're going to look at a 95% confidence interval. This is exactly like in chapter 6 when you found the middle 80% or the middle 60% or whatever like that. You're going to find the middle 95%. So when you draw out your picture, this part in here is 0.95. Okay, 0.95. Some things that you're going to need to know. This is like a fish. It's called alpha. This is the area in both tails. So in this case, over here, alpha would be 0.05. Since it's 95% confident, that means 95% in the middle, or 95.95 area. That means what's left over in the tails is 0.05. Alpha over 2 would be the area in one tail. So that's going to be 0.025. Okay, so 95% confidence interval, this is the picture you're going to draw. That's going to be no matter what percent they give you, that's what you're going to draw. Okay, just change that. Take half of what's left over in each tail. So what you need to do then is you need to look in the big part of your chart for 0.025. Okay, and it's right here, 0.025 right here. So negative 196. That means this one's positive 1.96. So the nice part is as soon as you find the negative one, you know the other one is just the opposite of that. Okay, so alpha over 2 is 0.025. And the formula that you're going to see on the next page, it looks like this, z of alpha over 2. Okay, so you draw this whole picture, and the reason is because we need to know what z of alpha over 2 is. That's going to be this one, 1.96. It's always your positive z-score. So even though you look up this one first, z of alpha over 2 is technically positive 1.96. It really doesn't matter which one you use because you're going to add and subtract anyway, but it is supposed to be the positive. All right, so z of alpha over 2 is the corresponding z-score to whatever alpha over 2 is. Okay, so when I ask you to find the 95% confidence interval, this is what you're going to set up. If it wants the 98% confidence interval, this is going to be 0.98. Means there's 2% left, which means 1% in each side, so 0.01. Okay, and that's how it's going to look every time. And again, really the only thing you're going to pick out in order to use in the formula is that number right there. Okay. So here's the formula, and it's going to look really, really scary, but hopefully it won't be too bad. Okay, so it's a really long thing, but if you notice, this part right here is the same part as this right here, only this has a minus and this has a plus. So what some people do is they write it like this. Okay, so then it's that, but you have to write it as an inequality. Okay, this one you're going to actually have to do a lot of writing. You're going to have to write an inequality, and then you're going to have to write a statement about it. All right, so this is, I'll give you both formulas on the formula sheet, but you have to write your answer as an inequality. Okay, we're going to ignore this part. Couple of assumptions that we need to do. First one is that the sample is a random sample. And then n has to be greater than or equal to 30, or it is normally distributed anyway. That just allows us to use our z-chart. Okay, so you're never going to have to worry about that. You're going to be able to do it for all of them. But that's what you're going to look out there. Okay, so when you read through your problems, you're going to want to pick out X bar. The Z of alpha over 2, you're going to have to calculate. Sigma is, remember, your population standard deviation. And then N is your sample size. Okay, so when I read through here, it says a sample of 50 cars, so N is equal to 50. They had a mean time of 54, so X bar is 54. Standard population standard deviation is 6, so sigma is equal to 6. Find the best point estimate of the population mean and the 95% confidence interval. So here's the first thing. This should be the easiest question to answer, but most people forget what it means. Find the best point estimate of the population mean. What we wrote up here, the best point estimate of mu, population mean, is whatever your sample is. You have nothing else to base your answer off of. Okay, just like if I would show you that picture, you just have to guess how old you think I am. Even though it's a sample, it's still a guess. All right, so the best point estimate is 54 days. That's it. So it should be simple, but a lot of people forget what it means or just forget to answer the question in the first place. So whenever asked for the best point estimate, it's whatever your sample mean is. Okay? Even though we already did the 95% confidence interval, I'm going to draw it out again just so you can see the whole thing. So this is 0.95, which means this is 0.25 and 0.25 to add to 100%. You're going to look in the big part of your chart for 0.025, and again, it's right here. Gives you negative 1.96 and positive 1.96. So Z of alpha over 2 is 1.96. So once you have all of that stuff figured out, you just fill in your formula. So I'm going to write the whole long formula out. 54 minus 1.96 times 6 over the square root of 50 is less than mu, which is less than 54 plus 1.96 times 6 over the square root of 50. Okay, so when you put this in your calculator, you want to just type it in. 54 minus 1.96 times 6 over square root of 50, 52.3. is less than mu, which is less than, so then here's a nice thing, you can just hit second enter, go back and change that minus sign to a plus sign, 55.7. Okay, so here's the first part of your answer, just the inequality, then you have to write it out, and here's what it means. You can be 95% confident that the population mean is between 52 and 56 days. Okay, so that's why I was saying your answers are going to be long for these. First thing is we had to do the best point estimate, then we had to calculate it and write it as an inequality, and then you need to write it out. Okay, so you're 95% confident that the population mean is between 52 and 56 days. What you have to remember is that is based on one sample of 50 cars is all. We could do this again and come up with a completely different interval, but you just do, this is what we know based on the sample that we have. So again, someone else could do a completely different sample and come up with maybe 30 to 35 days. So it all depends on what your numbers are, but according to our data, this is the best interval estimate that we can give.